In this video, we want to integrate this integral here using the U-substitution. U is equal to the square root of 1 minus e to the x. So the objective then is to transform this integral into one involving the variable u. And again, there could be more than one substitution that'll work. This is one that will. If you find another one, put it down in the comments, please. So for this one here, the square root of 1 minus e to the x, that's going to be your u. I'm going to square both sides here, solve for e to the x, find du, so I can get a substitution for dx. So here's the setup. U again is equal to the square root of 1 minus e to the x. I square both sides. The radical cancels on the right side. And then I solve this for e to the x. Why did I do that? Because in the setup, you're going to wind up with an e to the x. And when we transform this integral, we have to have just u's, the variable u. We can't have an x or something involving x, e to the x, and so forth. So I get e to the x is equal to 1 minus u squared. And then from the first part here, the first setup here, u squared equal 1 minus e to the x. I take the derivative there. I get 2u du. Derivative of 1 is 0. And the derivative of minus e to the x is minus e to the x. So I get dx, minus e to the x dx. So when I solve for dx, divide by minus e to the x, both sides here. So I got then u squared is equal to 1 minus e to the x. Like I said, solve for e to the x. Then take the derivative of the first statement here, u squared equal 1 minus e to the x. I get 2u du equal minus e to the x dx. Divide through by minus e to the x, I get this right here. Now I have something in terms of dx. I also do not want this in there, because I'm plugging into the original integral, so that the e to the x gets replaced by this, 1 minus u squared. So with that, we can come over here then, make the substitution. So dx gives me a minus 2u du. And then the square root of 1 minus e to the x, like we said, this is the u. And then this part in the bottom here of the dx, that's e to the x. And that gets replaced by 1 minus u squared. I get this. And then this is a u, and this is a u. Those divide out. And I got a negative right here. I'm going to bring it to the denominator, and this will become, instead of 1 minus u squared, I'll get u squared minus 1. So the integral becomes du, the negative went to the denominator, so I have my 2 there, and then this became u squared minus 1 du. Now this is a rational expression in terms of u, so I could factor the denominator into u minus 1 and u plus 1 and use partial fractions. So this is going to give me then the integral of, this is going to be 2 over u minus 1, u plus 1. So that can be broken up into partial fractions. Since we have linear factors there, some constant a over u minus 1 plus some constant b over u plus 1. This will be du. And these will be easy to integrate once I know the a and the b, because all it's going to be is ln of absolute u minus 1, ln of u plus 1, multiplied by whatever the constants are, a and b. But that's your setup. So here we have it. Now I could multiply both sides and get 2 multiplied by the LCD, the u minus 1, u plus 1 would cancel. I'd get 2 equal to a multiplied by u plus 1 and b multiplied by u minus 1. Get a system of equations, because that's an identity. Or I could use the cover-up method. That works nicely when you have linear factors, first-degree factors. So let's see, I cancel this. Cover up. When I find a, I cover up what's under a. And then what makes that factor 0? 1. So I replace the u here by 1. I get 2 over 2 is 1. So I get a equal to 1. That's how easy it is with the cover-up method. Of course, you can do it the long way. Now suppose I wanted to find b. Cover up the factor that's under b. And what value makes that factor 0? negative 1. So plug in negative 1 on the left side. With this one covered up, I get negative 1 minus 1 is a negative 2. Into 2 is negative 1. So B is equal to negative 1. That's how you do the cover-up method. Now this is going to work if they're all linear factors, they make it real easy. Now that sometimes you can have a combination of linear factors and nonlinear factors, quadratics. It's still going to work to an extent, but you might have to do other things like get some other equations to find it. But in this case, we have it. We know the value of A. Let's just come back over here then. Know the value of B. So A is 1 and B is negative 1. So we'll proceed here and say this is equal to, now we just integrate term by term, or in this case, rational expression by rational expression. So we have the integral of 1 over u minus 1. That's just going to be the natural log of absolute u minus 1. But remember, we always go back to the original variable. So what is u? U is the square root of 1 minus e to the x. So we got the integral of this first one here is natural log of absolute square root of 1 minus e to the x minus 1. But the u, like I said, was the square root of 1 minus e to the x. And then we have a minus. Same thing with the second integral. Integral of minus 1 over u plus 1 is the natural log of absolute u plus 1. But again, u is the square root of 1 minus e to the x. And it's a plus 1. And this is plus the constant of integration. Now you could leave your answer. Now you could leave the answer in this form here. Natural log of absolute square root of 1 minus e to the x minus 1 minus the natural log of absolute square root of 1 minus e to the x plus 1 plus the constant of integration. Or you can use the property of logs. If you have a difference of logs, you can write it as the, in this case, natural log of a fraction. So this can also be written the natural log of the square root of 1 minus e to the x minus 1 over the square root of 1 minus e to the x plus 1. So you can leave your answer in that form. Natural log of absolute square root of 1 minus e to the x minus 1 over the square root of 1 minus e to the x plus 1. And of course, plus the constant of integration. Thanks for watching. We'll see you next time.